Hello everyone. Today we're going to finish 12.1 day 3 and we're going to be modeling with real-world situations using arithmetic sequence, continuing with the explicit rule and the recursive. In example 1, a student with a part-time job borrowed money from her parents to purchase a bicycle. The graph shows the amount of students owes her parents as she makes equal weekly payments. And the amount shown is shown only for the first 5 weeks. So we can see that at week 0, before the student makes any payment to the parent, the payment on that loan is 800. So we know that S of 0 is 800. So if we start 0 at 800, and it looks like it's going down by 50, so week 1, they will owe 750, and week 2, 700, 650, 600, and 550, so on and so forth. So continuing, that will be up to week 5. And we notice that again it's going down by 50, so D is equal to 50. And we are going to write the function using f of 0. So the f of 0 using the first week at 0 of 800 is f of 0 plus the common difference times n. So substituting week 0 is 800 plus common difference is actually negative 50. So we have minus 50 times n. And that will be the equation that is used to represent the function. And they want to know after how many weeks will the loan be paid off. So we're going to assume that the balance needs to be 0. And we're going to solve for the equation minus 800 from both sides. We will have negative 800 equals negative 50n. Divide negative 50 and we will have n equals 16 weeks. So in about 4 months, the student will be able to pay off the parent. And question 2, the number of seats per row in an auditorium depends on which row it is in. The first row has 6 seats, so we're going to start filling out this table here. Second row has 9, third row has 12, and the fourth one has 15. So filling out the table and then use it to write an explicit rule. So we're going to use the explicit formula f of n equals, since we're starting with the first row, we're just going to use the one that has f of 1 plus d times n minus 1. So following, substituting the first term in there is 6, and then the common difference in this case is actually a plus 3. So we're adding 3 per row. And so therefore d is actually equal to 3. So 3 times n minus 1, and we have 6 plus 3n minus 3, and then we can rewrite it as f of n equals 3n plus 3. And that will be the equation that represents this situation here. The next problem is a triad problem, so make sure you pause the video at this point before you go on to look at the solution. So hopefully you've had a moment to try the problem before you look at the solution. Let's take a look. It says write a recursive and an explicit rule. So I have set it up here to do both methods. The starting salary of a summer camp counselor is $3.95 per week. So we know that in week 1 you get paid $395 as a counselor, and then it says increases by $45 each week. So that means that week 2 this person will be making $440, week 3 $485, so on and so forth. And based on this situation, we can make an equation that represents this, and we know that D is actually equal to 45 because you're getting an increase of $45 every week. So f of n equals week 1, f of 1, which is $3.95, plus $45 that's the common difference, times n minus 1. And continuing to simplify the equation, that will be a plus 45n minus 45. And we will have 45n plus 350. And so now the next part says if the ending salary is 710, so the equation is going to be 45n plus 350. But if we want to end with 710, how many weeks does it take for you to reach 710? So we're going to let f of n equal 710 and solve for n. So minus 350 from both sides, we will have 360 equals 45n divided by 45, and we will yield n equals 8 weeks. So it will take 8 weeks for the counselor to reach. So the camp actually ran for 8 weeks because that's their ending salary. So let's take a look at the recursive rule. For using the recursive, we're going to state that f of 1 is equal to 395, and f of n is the previous week. That's f of n minus 1 plus $45 every week. And we're going to say that that starts from n, the term equals week 2 and beyond. So that's how we state it, as n greater than or equal to 2. And that's the end of that problem. And the next problem, again, make sure you pause the video and try the problem before you actually look at the solution. Hopefully you've had a chance to try it. Let's take a look at the problem. Again, it's asking you to write a recursive and explicit rule. So I have set it up here to do both. And then let's take a look at the problem. The graph shows the length in inches a row of grocery carts when various numbers of carts are nested together. What is the length of a row of 25 nested carts? So based on this pattern here, we have row 1 has 38 carts, and then row 2 has 50, 3 is 62, 4 is 74, and row 5 is 86. So so on and so forth. It continues. And we can tell that you are adding 12 more carts each time for each row. And so we know that D is equal to 12. So based on this equation, we can write that equation for the function, which is f of 1, that's 38, the first number, plus common difference, which is 12, times n minus 1. Simplifying, we're going to have 12n minus 12, and we have 12n plus 26 is the function. So f of n is equal to 12n plus 26. And the question is asking, what is the length of 25 rows? So we're going to let n equal 25 and substitute 25 into the equation. And we will have 326 inches. That is the length of the 25th row if we continue this pattern. And let's take a look at the recursive. Recursive, we're given the row 1 is 38. And then for the next rows, it's going to be the previous row plus 12. And that's how many? And then that is going to be for the second row and beyond. And that is how you write the recursive method. Those are all the problems that we have for examples. Hopefully that helps. And let's go ahead and address this discussion question. What is the difference between the graph of an arithmetic sequence with a positive common difference and the graph of a negative common difference? So I've given two examples when common difference is 5 and negative 3. So when we have a positive common difference, you're going to have the graph going up in the motion, like a slope of a positive number. So when you have positive slope, the graph is going up. And when you have negative slope, the graph is going down. So that would be the difference between the two. And that is the end of the lesson. Don't forget your homework is to finish the book set and HRW, and then take notes for tomorrow's lesson, the next lesson, 12.2 day 1, and then Alex. And have a good day.